Very good afternoon to all. In this lecture, EC8652 Wireless Communication, Unit-1 Wireless Channels. In previous classes, we have to discuss the large scale model, path loss model, and also small scale path loss model, the link budget design analysis, and also the time dispersion in the multi-path channels. Now today we are going to discuss about the topic fading due to multipath time delay spread. Already we are discussing the fading effect. There is a small scale and a large scale fading, how to induce the fading effect in the multipath mobile communication channels. So here the fading takes place in mobile signal propagation due to the multipath time delay spread. In this fading are many types. That is a flat fading. Number one is a flat fading. Number two, frequency selective fading. So both are the based on multipath time delay spread. And the second category, the Doppler spread, that is a fast fading and also the slow fading. In this different fading type occur depending on the region through which the mobile signal traveling. So the based on multipath time delay spread, the number one is flat fading. The flat fading, we can move to the flat fading. It is the bandwidth of the signal is less than the bandwidth of channels, and then delay spread is less than the symbol time period. And the second category of the frequency selective fading is a bandwidth of the signal is greater than the bandwidth of the channel. It is a opposite conditions. And the delay spread is greater than the symbol time period. Now the time dispersion generated due to the multipath will make the transmitted signal to undergo either frequency selective fading or flat fading. Now in this presentation, the flat fading, the received signal in mobile radio will undergo the flat fading effect if the channel have linear space response and a constant gain over a bandwidth is greater than the bandwidth of the transmitted signal. But the spectral characteristics of the channel will preserved at the receiver end. At the same time, the strength of the signal received will change from the time to time due to the multipath effects. It is one of the important that the gain of channels changes over a time, then amplitude of the received signal will change. At the same time, the spectrum of the transmitter signal will be preserved. So the flat fading channels are also called as a amplitude varying channels. Amplitude varying channels of narrow band channels, because the bandwidth of applied signal is narrow when compared to the flat fading, the bandwidth of the channels. In this design aspect of radio links, the distribution of the gain of the flat fading channels is important, and generally the amplitude distribution used in the common distribution techniques. So the signal will undergo the flat fading effect when the bandwidth of the transmitted modulation is lesser than the concurrent bandwidth, and the RMS delay spread is less than the reciprocal bandwidth. Okay, now what are the demerits of flat fading? The flat fading channels will cause the deep fades and it more transmitted power is required to received signal with low bit error rates. Now we can move to the frequency selective fading. The frequency selective fading placed in received signal if the channel has a linear phase response and a constant gain over a bandwidth which is a smaller than the bandwidth of the signal being transmitted. In this case of fading, the impulse response of the channel has multipath delay spread that is greater than the reciprocal bandwidth of the transmitted message waveform. Due to this, received signal will also consist of multiple versions of the transmitted signal that is attenuated and delayed, resulting in distortion of the signal. This frequency selective fading is mainly due to time dispersion of the transmitter symbol with radio channels. The channel will also increase the problem of ISI, that is a inter-symbol interference. It is also complex to model a frequency selective fading channels than a flat fading channels due to the two reasons. Number one reason, each multipath signal has to be modeled. Number two, channel has to be considered as a linear filter. So the statistical impulse response like a two-ray fading models or measured impulse response may be used for analyze the process of frequency selective small scale fading effects. In this frequency selective fading, the gain is different for different frequency components, but the channel is frequency selective when viewed in a frequency domain. It is mainly caused by several multipath delay that may exceed the symbol period of the symbol transmitted signal. In terms of wideband channels, because the bandwidth of the channel impulse response is not wider than the bandwidth of the signal, that is input signal S of t. In general, we have to the concurrent bandwidth BC is less than the bandwidth of the transmitted modulation, and if the reciprocal bandwidth is lesser than the RMS delay spread of the channel, then the probability of occurrence of the frequency selective fading is more. Now we can move to the Doppler on Doppler spread. It is based on Doppler spread. There are the two different techniques, fast fading and also the slow fading. The fast fading and the slow fading is one of the concurrent time period and Doppler levels depending upon the concurrent time period and also the Doppler spread. Now today the conclusion of the topic of time dispersions and also the fading due to the multi-time delay spread, including the flat fading and also the frequency selective fading. In upcoming lecture we are going to discuss the fast fading and slow fading effect in the multipath channels. Thank you for watching this video.